Good morning, dear students. This video is recording inside the Adi Institute of Engineering and Technology, and this video is lost for about 5 to 6 minutes. In this session, you are going to learn how to deal with Code Composer Studio. Basically, I am using Code Composer Studio 3.0, and let us see how to use this Code Composer Studio in the semester for R16 regulation in digital signal processing laboratory, right? So let me start with, I have already installed this Code Composer Studio 3.0 in my laptop. So let me start with, so the moment I start, so it is asking me to choose the processor on what I am going to work. So it is hard for me to search all the devices, all the processors, rather than I use some filters to select. So here, as per the curriculum, we are going to deal with Texas Instrumentation DSP processor 67XX. So I am choosing that, and I don't use the DSK kit. I only use simulator, so I am going to use the simulator, selecting the simulator, and I am taking the little, and so that you can see the list of processors here. So I am going to select C6713 device cycle accurate simulator little, and I would like to import that to my project. So I am importing it, and let me save and quit. So upon saving and quit, it is asking me to start the Code Composer Studio upon exit. So I just start that. So let me start this. So I am starting the Code Composer Studio now in this device. So it may take a bit, so please wait a while it is getting initiated. Yes, so you can see a window like this. So particularly, and in this window you can see there's so many options. So I would like to create a project now. On DSP 6713 kit. So let me go to the project. So I would like to create a new project. So go to the new project. Here my project, let me name it as demo, demo underscore 1. I would like to create this project as a demo 1, and here in this demo I will write a program and run the program for particularly linear convolution and circular convolution. In detail, I will explain with the linear convolution. In the same way, you can do the circular convolution also. If the code is available for you, you can write the code and you can develop the code in using simple language called the C programming. Okay. And the location, the project will be created in the CC Studio My Projects in demo. A folder will be created automatically. And the project type is basically it's a .out file will be created, and we will execute that .out file. And the target processor here I am using TMS 320C67XX. It was developed by Texas Instrumentation in India, which is located in Bengaluru, and this is basically an American based company for your information. Okay, so let me create my project by clicking here, tapping on finish. So finish. So it is asking me, it's already existed, whether to overwrite. No, I just okay, then I just create like demo. So let me tap on finish. So my project is created. Now after creating a project, I want to write the code for it. Particularly, I would like to write the code for linear convolution. So let me go to the file. Here I am tapping on the file and tapping on new. There I got two things. One is source file and the other one is DSP or the BIOS configuration, and here I go with the source file. So here is the source file. Now I would like to write code for the linear convolution. So entire logic will be developed here only using the C programming commands. So I have already written. So here is the code for that. And here this is ash include std.ioh. This is a header file. We need to add everything while you write a develop a program or logic in the C programming. And this is a header file. In this stdio standard input output library header file, so the printf and the scanf functionalities and how they have to be work and perform the operations will be saved there. And I would like to declare the few variables called int x of 20. Of course, the register in order to avoid some conflicts, I am just giving here 20. So can the array I can give up to 20. Okay, and h is also 20 and y is 20, but I don't give up to 20 because if I give 20 the output may vary, so that the y variable will not be sufficient. So I will use just 4 to 5 locations only. So I'm just giving here x equal to 20, h equal to 20 and y 20 sizes, and n1 and 2 small n and small n for to run the internal loops. Okay, to develop the internal loop. As I forward to the program, you can understand why I have created these variables. Particularly in the case of C, we need to define these variables in the starting only. Of course, I am declaring these variables as a global variables, so I can use these variables in the entire my program, right? So printf. So here I need to know what things I have to enter here. So to enter the length of the input sequence, and by using scanf function I will read that number, and again the impulse of the response of the length of the second sequence and the variables in the sequence. For this I am using the for loop to scan that. So based on the capital N value I will read how many values I need to read. Okay, and this is an array. And similarly I forward this entire program up to here, and the actual logic starts from this line for n equal to 0 to n less than n1 plus n2 minus 1 n plus plus, so that the final length of the program could be length of the first plus the length of the second sequence minus 1, that would be the length of the final sequence. So the length could be n1 plus n2 minus 1 in the linear convolution. And here I have declared y of n equal to 0, and the n equal to 0 for y of 0 it is taken already 0. The reason why I have given like this, because I would like to develop a logic y of n equal to y of n plus x of m into h of n minus 1. So initially if I want the first sample to be calculated, I need y of n here. Obviously I need to take 0. So for that I am taking 0, so that 0 will not show any difference, will not affect the logic for producing the first sample. Okay, so after producing the first sample, like in the for loop all the samples will be created in the same way by doing convolution, and the result should be displayed. So for that I have again developed a for loop to print. So for n equal to 0 to n less than n 1 plus n2 minus 1 n plus plus, and I am going to print here, and this is my logic. Okay, so after this I need to save this file. So let me save this file for the first time. So yeah, you can see here it's a pjt project file, demo project file. Yes, and this is demo underscore lc, because it is a linear convolution, and I need to, and this is the name, demo underscore lc is my name, and I need to save this file with a .c extension. So .c, because this is a particularly a C file, so that is why I kept here the .c, right? And this is a source file C. Yes, so let me save this file. So upon saving this file, you can see some changes in the color. If it is a commands, it will be taken in the blue letters, and if it is a neglecting text whatever we created for the user, so it is mentioned in the red color. The logic is entire, the logic is in black color. Okay, right. I have saved this file, fine, but I need to add this code or the code file to my project. So for that what I do is I go here and the right click, and then you can see the list of options there. I can go add files to the project. So add files to the project, and sometimes it will be like this, and some list of files will be there, or some other file type mode it will be in. Then you may not see any files, but you need to keep here C source files. The moment I tap on C source file, I can see here the demo underscore else. Otherwise, it is better to choose the all files, so that we can see all category of files here. So demo underscore LC is the required file I need to add to my project. So open. So that the moment I do that, I can see demo underscore LC dot C on my screen in my project file. Well, fine. So this is basically C is a high level language, but what really a processor need is a assembly level language, or the machine. Obviously, the machine level, the machine always needs a machine level language. So it need to be converted into the machine level or high level language, right? This high level language should be uh, converted into assembly level language. Basically, I know Telugu, and some other person may know English, but so if I want to convey my information, there should be someone to convert this Telugu into English language and English into Telugu language. For that, I need to we have some assembly files. So those files will convert this high level text language into the processor understandable language. Okay, for that I need to add some files. So those are library files for that particular processor. We will see as the video forwards. So add files to my project. So let me add files to my project, and I navigate to uh, local disk C. The means where I installed my software or a tool, Code Composer Studio. There you can find Code Composer Studio folder, and I go to the Code Composer Studio. There I can see the list of the so many list of the folders. Out of that, I need to go to the C6000, and here in the C6000, I need to navigate to CZ Tools. I need to navigate to CZ Tools, and I need to go to the LIB, and then some the library files will be, you can see here. So based on the project, you need to select the library file, and here I would like to select C6700.lib or TS6700.lib. This is a file I need. So let me open this. Open. So the moment I did that, in the libraries, some library file has been added, and one more source file I need to add, because so this is a library file for the tool, and particularly for processor, there we need to add some file. I would like to here use DSK6713 processor, DSP processor. So for that, I need to add a source file. So let me add one more files to my project. To add files to the project, then I need to go to the CC Studio, and then here if you drag to the bottom, you can see tutorials. The tutorials, you can see DSK6713 set. Here hello1 is a folder. Inside the folder I can see a file. This is a Windows command script, basically a CMD file. So I would like to add that file to my project. So let me add that file to my project. Right now you can see here a library file RTS6700, a source file demo underscore lc.c file, and a hello.cmd file. Now I am ready. I'm ready to debug my program. So let me go to the project, and let me go to the project now and tap on build my project. So let me tap build. So it is building the project. Excellent. Now in the build completed, I got 0 errors, 2 warnings, and 0 remark. Obviously I need to consider if any errors are there, because it may affect the logic, but I got 0 errors, and 2 warnings I can consider. It is not my choice to consider whether to consider or not. Okay, and I have built it. Fine. And the out file will be generated in the .out folder, and that out file I need to call here. So let me call that by going to the file, navigate to the file, tap on it, load programs to this, load program. Here a folder will be automatically created if it is successfully built. So a folder name debug. So double click on it and you can see demo.out file here. So let me tap on this, open. So opening this, I got something on the window, and basically you can see if you already completed the microprocessors lab, you can see there this is basically an offset address, this is a base address, and this is an offset address, and this is a command, and this is the instructions or of opcodes, right? These are the opcodes. These are basically the operands, and this is the opcode. MVK dot S2 is an opcode, and this is an operand. And these are offset address and base address, right? But you can't write this entire code because I already mentioned writing code in assembly language is very tough, and it is application specific and processor specific. So you can't write so many things based on the processor. If you know how to write a logic in the high level language like a C, Java, you can convert that programs into the assembly level language by using this process. Okay. So I have already written my logic using C programming. So let me run this by going to the debug, and here you can see run means F5. So let me run this. The moment I tap on it, it is asking me a dialog window is open, standard input output dialog box. So here let me take the length of the first sequence be the 4. So you can see enter the length of the input sequence x of n, n1 equal to 4, enter, and enter the length of the impulse response h of n, and I'm taking just 4 again, enter, and enter the 4 samples for the input sequence x of n. So 1, enter, 1, enter, 2, enter, 2, and so the initial x of n sequence I have entered as 1, 1, 2, 2. Let me enter the same sequence, and I can go to the different sequences also. Otherwise I can go to the 1, 2, 3, 4, the impulse response h of n equal to 1, enter, 2, enter, 3, enter, 4, enter. So the moment I have given all the inputs, I got the response y of n equal to 1, 3, 7, 13, 14, 8. So this is the output. So output is successfully executed, and I got the response for an LTA system y of n equal to 1, 3, 7, 13, 14, 14, 8 is the linear convoluted sequence. For if I do the convolution for the input sequence 1, 1, 2, 2, 1, 2, 3, 4, I got the output sequence as 1, 3, 7, 13, 14, 14, 8. You can see on the screen. Okay, fine. I would like to see in terms of a graph like visualization, because if it is a less data, I can easily read it out. And but if at all, if it is a large data, because in the real time we deal with a large amount of data, large in the 1,000 samples, 2,000 samples, like thousands and thousands of samples we deal with. That is why I recommend to see the samples in terms of graphs, so that if at all you visualize some data in the terms of graphs, you can estimate whether the data is increasing as the time forwarding or decreasing, or what happening, you can estimate basically. So let me go to the view, and then here you can see the graphs. So I am seeing here the graph, the time frequency graph basically. And here some options have been given, and the starting address it is given like some address, but I don't know what is the starting address. So I would like to draw here the response y of n. That is why I keep here the variable called y. Okay, And the acquisition buffer size means it will display all the buffers, so I don't want to see all the buffers. I would like to see just 20 buffers or a 10 buffer space. So let me go with a 10. Yes. And it's a display data size also. I'm not displaying the much amount of data, hardly my data 1 2 3 4 5 6 7 7 samples. So let me distracted myself for this also for third time. And here I can see here data plot style is a linear plot style, fine. Here the magnitude display scale is also linear. Let me check these options. Yes, the data plot size, if it is linear, it is a continuous curve I will get. If I kept here the bar, it will be drawn like this, the vertical, in a vertical term, so that the points will be connected, the vertical to the base axis. So we can expect this is a like samples, so discrete time signal. So let me click on OK now. So okay, so the moment I tap on OK, I got my graph like this, and this is a zero axis, and from that zero axis I got what these samples like this, so you can see it is something, and the highest sample is 14. So now my job done, and I executed this program, the linear convolution, using this code composer studio on DSP 6713 device, cycle accuracy on the simulator. Yes, thank you very much for listening to me. And if at all you can start writing your program, not only for the linear convolution, you can write for any logic, you can execute in the same way, but all the source files or the hello CMD files you need to add for this project. That's it for the today, and thank you very much for listening to me. This is Kishore Kumar. Thank you.